I'm Teresa, and this is Ian.
Today we will be talking about the giant crystal formation in some caves. So how I think they form is two reasons. Um, the heat of the core is more radiant there. It's more hot, I guess, there. And
Okay.
I know that affects crystal formations, and it would especially affect these huge crystal formations. Also, the Titanic plates moving would like kind of probably shake them, and like it would be like spinning about around a water bottle. The water would stay at the bottom, hold it up top while spinning it.
Okay. So, um, that I think what you're saying is that the center of the Earth is super hot, and that the heat and the plates moving around, that's what creates the conditions for the giant crystal formation.
Also, there are probably hotspots of heat, and that's probably one of those hotspots.
Okay. Are there places that have bigger crystals? You said giant crystals.
Huge.
Are there places that you have in mind that you were thinking about?
No, I can't. It was like a year ago when I saw this, and I never really. I kind of forgot about it, but now I'm curious because you know giant crystals. Normally, you can only find a block with quartz because these were quartz crystals, and so you can only find quartz blocks, and you can find very few of them, like easily. Yes.
Yeah. So I typed in giant crystal formations into Google, and I saw this really great article on National Geographic. And it goes into sort of what you were talking about is these gigantic like areas that have these gorgeous crystals, some up to 7 feet long.
But
Um,
how do you think they formed
how
before?
do I think they formed?
Yeah, how do you think they are so, like you said, 7 feet long?
I mean, I have very little understanding of the formation of crystals other than like the structure of them.
Yeah, I'm pretty sure it's
So
something.
crystals are like a repeating structure.
Oh yeah,
And I suppose, given enough time and energy,
yeah.
things could be formed of incredible size.
Also, some of the Titanic plates might have hit and caused immense heat in that region, and because of the cave, it probably stuck around for years.
Yeah, that makes a lot of sense. So, anytime you have a lot of force and a lot of heat,
Friction.
that's basically all of chemistry, right?
I guess.
You guess. I mean, obviously not all of chemistry, but those are catalysts for change, is when you have, impact or force and heat.
Yeah. But I guess now we'll look at the article and see if we are correct.
Sure. So this article says that scientists at the University of Granada think that the formation involves a combination of cannibal chemistry. It's tiny crystals being feasted on by their bigger siblings and ancient climate change. This sounds like some type of a weird sci-fi novel.
So I'm thinking what it means is like the crystals kind of form, and then other crystals get bigger at a faster rate and kind of engulf the smaller crystals. And it's like process of elimination. The smaller, slower growing crystals get like weeded out by the bigger crystals, which just engulf them. It's like if
That's
you
exactly, yeah, that's what it's saying.
it's probably like a
And
tree if there's something in it. Just heals around it.
well, I can barely hear you.
Oh, so it's probably like a tree healing. It's if you put something into it, the tree just heals around it.
Yeah, this says that a rock cavity, so holes that were once gas bubbles escaping from magma, so like a cave or cracks created by tectonic activity, is
Yeah.
infiltrated with hydrothermal fluids. You know what a
Ooh.
hydrothermal fluid is?
No. So
Let's
a really
see.
hot fluid.
I think so. I want to say it's something that is only a liquid at high heat.
Yeah. So like rock, magma.
Right.
Or something that is odd because it doesn't disintegrate in high heat when it's normally would disintegrate.
And then once inside, their dissolved elements can crystallize on the walls. Stable temperatures, plenty of ingredients, and a plethora of time tend to result in larger
So
crystals.
what I'm thinking, the hydrothermal liquids would come out. It would be a stable temperature, so they would form. They would solidify, and then more and more hydrothermal fluids would come at, I would think, would be a constant rate because the magma air bubbles are just like it's like if you pop a balloon. It's really small, I imagine, and it just slowly comes out.
Hydrothermal, well, I've got to interrupt you a little bit because hydrothermal fluids are seawater with tons of other elements and minerals in them.
So the seawater would probably disintegrate, leaving minerals behind.
It would evaporate
Yeah, evaporate.
because that's what the water does.
Yeah. And the only thing keeping it there was, I don't know, weird stuff happens at high heat.
Yep.
I mean, I guess it would just be evaporating and then come back, evaporate, come back, because you wouldn't lose any water, because that would be destroying matter. And so it would just be, it would disintegrate and come back and over and over and over again. And I guess some of that is,
You mean evaporate?
yeah, evaporate and come back over and over and over again.
So, absolutely. And it goes on to say that some of these have been growing for up to 2 million years.
That makes sense.
So that's definitely a lot of time.
Yeah. That makes sense. That's why they're so big.
There's also some something called a Ostwald ripening, which is where crystals dissolve into that hydro or what's it called hydrothermal fluid or the seawater mixture. The crystals like redissolve because the water's hot, and then they form into even bigger. Um, I found out that that type of larger crystal formation is called the Ostwald ripening. It is partially to blame, but it might be more about the temperature that might be what matters more because warmer weather seasons would provide more water and drier times would allow some of the chemicals to become brittle and break. Well, I think your initial theory that, or your initial hypothesis that large crystals were formed because of heat and tectonic plates moving about is partial, like that's part of the story, but that it's more complicated, as most things are.
Yep. And humans can't even comprehend how long it would take, not even to form that big of crystals, but to form normal crystals, it takes centuries.
Yeah, so in the laboratory, we can create crystals much faster
Yes.
because we know how to create the conditions.
Yeah, and we know how to maximize the conditions to create crystals as fast as crystals can be created.
Right. But there is no replacement for, we don't have the ability right now to create a 36-foot long solid crystal
No.
with this type of process, right? We have ways in the laboratory that we can create something very quickly to match it, but there is something almost magical about the idea of these gigantic crystals forming layer by layer, year by year, and it taking such a long time.
Like super speed time lapse. Like if you went back in time 250 million years and started this, I can put a camera down. And some, like, I don't know, infinite clean energy. Because it's in the future. You would have to literally be like, I don't know, 120 frames per second, like a couple thousand years per frame.
And then I think it would be easier to just create a simulation.
Yeah, that would be easier than having to show the warping of time and space.
Yeah, I would love to know how to bend time and space to accomplish something like that. Take a camera back 250 million years ago.
Yeah, that would be
but obviously no one has that technology yet.
And your camera would probably be engulfed by one of the crystals.
Oh, that's an excellent point. Although, if you could go back in time, you could probably just move it periodically.
Yeah.
anything else you would like to talk about as far as these crystals?
No.
Do you want to look at some pictures of the crystals?
Yeah. We can show some pictures up on screen.
Yeah.
So here are some pictures.
So the first one is of people going down a cave. It's called spelunking in the Greenland ice sheet. It's a glacier cave. So seasonal melted seawater cut giant holes into a giant glacier, and it's become like a hole that they were able to climb down into. It's very dangerous
Yeah, if you fall, you
because
probably.
glaciers are constantly moving about.
Yeah, especially if there's an earthquake. So that's a big no for me.
Yeah,
I would not want to go do that.
You would not want to do this?
No. Yeah, that's what I said.
All right, here is a picture of a lava tube cave. It's an underground structure formed because of lava flowing through.
That sounds reasonable.
It does. A Patagonian cave. It's in Chile. It's made out of limestone.
Yeah.
And this is formed because of a slow movement of water chiseling away limestone.
Like the Grand Canyon.
Yes.
But
exactly. Except the Grand Canyon is sedimentary rock.
Yeah. But limestone is much.
You know the difference between. What's that?
Limestone is much softer. I imagine it would be easier.
Yes. And it's soluble, which means that it can be dissolved in water.
Yeah.
This is a Greenland glacier cave. That looks more like a swirling galaxy.
Or red spot.
There is a what?
Or the red spot on Jupiter.
Or the red spot on Jupiter, yeah, the red storm. Yeah. This was caused by a geothermal spring.
Yeah, that sounds reasonable.
Oh, this is beautiful. This is called the Reed Flute Cave in China. It was created by an underground river.
So on the bottom is like the lake, and then on the top are the stalactites, and then
I think so.
And then the rock formations coming out of the water.
Yep. That appears to be accurate. That is gorgeous.
Yeah, but on the reflection it looks like a city.
It does.
What is that?
This is crystal clear water surrounding stalagmites in a cave in New Mexico.
Okay.
All right.
It looks like a painting.
It does look like a painting. I'm having trouble visualizing standing in there.
But what's inside of the stalagmites? Is it just a hole?
I think it's water. It's just
But
water.
isn't there water around it?
Um, maybe.
Huh.
There's more pictures online.
We'd have to be there.
Um,
Maybe someone can break it down in the comments.
yeah, if you happen to know, please share in the comments below. We'd like to know more about it. This is these are calcium deposits that are up to 50 feet tall.
Yeah, it's probably pretty hard to load, especially to make in that structure. That would be hard.
So I thought calcium was actually a pretty soft element.
Is it?
Let's see. So according to livescience.com, calcium is a soft, silvery white alkaline earth metal. It is never found in this state in nature because it's always in some type of a compound. So limestone is calcium carbonate, so that's calcium and
That would
carbon.
make sure, with that connection, that would make sure that that would justify why limestone is so soft. You know, because
Right.
it's not only calcium, which is already soft. It's a mixture of calcium and something else, or
Correct.
calcium oxide.
So this is calcite.
Yeah, I know about what limestone.
Limestone is calcium carbonate.
Yeah, so calcium carbonate is probably softer than calcium.
No, it would be pure pure calcium is very soft.
Yeah, but what about calcium carbonate? Is it hotter?
It would be harder than it would be tougher, harder than pure calcium.
Red?
Yes.
Okay.
So those columns are made out of calcite.
Like that one, I imagine it would be like a river, like water running down the side of a cliff, and it would erode unevenly, and there would be pockets of water just moving around, and yeah, and I imagine that would be what created the crevices.
Yeah, so according to the scientists who have studied it, it's from water levels repeatedly going up and then down. So like a river where it changes how deep it is over time.
Okay, so it would stay in one place for a little bit, erode at that for a while, go a little lower, so it would like leave little indents.
Exactly.
Okay, I think that's a good stopping point.
Okay. Do you want to see the last two?
Yeah, sure. There's only two more.
Yeah, there's only two. This one looks very weird.
So
It's called a cave pearl.
what are these?
So these are when layers of calcite slowly form around a grain of sand.
So it'd be like a piece of sand. It would be like if a crystal forms around the sand, but it wasn't a crystal, it was more of a waxy coating that hardened. Would that be like how would these form?
So it's made out of the exact same stuff as in the previous picture.
Yeah.
It's the exact same deposit. It just forms in a different way because of the tendency of things to clump together.
So how is it not falling apart then?
Because it's flat. So the formations form from the bottom up.
So why aren't they falling apart?
Because there's nothing to disturb it.
Yeah, but is it solid?
It is solid.
Oh, so did it solidify?
Yes. It is solid. You could pick up a giant chunk of it and it would have all the little pearls on it. They're not individual pearls.
Okay.
And this one is underwater.
I don't see it. Oh, there it is.
No. Okay. So it is a flooded cave. They're down there with fish. I feel like I've seen this in a video game.
It looks like
Doesn't it look like an underwater cave in
Subnautica. I think that was the game.
maybe there's a Lego game that there's a large part of the game under the ocean. I think that's the Lego Avengers game.
Wait.
Maybe.
Okay, so that was the last picture.
Yeah.
How do these?
So we learned a lot about rocks and crystals.
Yeah, that was cool.
That was very cool. So thank you for having this conversation with me, Ian.
And thank you too.
All right. Bye.
Bye.